Hello, everybody. If you're like most students, you may have trouble knowing which kinematic equation to use when. And during an exam or a test, your brain can completely freeze when you look at these five equations, not knowing which one to use at that time. Well, today I'm going to show you something your teacher may or may not have shown you, how to choose the proper equations by creating a kinematics equation flowchart. And the trick to this is you don't actually choose the equation. Let the missing variable choose it for you. Now, I know that sounds like a bunch of Yoda talk. So what does that actually mean? How can I not choose the equation and let the variable choose it for me? So in order to do that, let's go ahead and figure out what our variables are. So our five most common variables are VI, which is initial velocity. We have VF, final velocity. We have acceleration. We have time, which is T. Oops, that's supposed to be an arrow. And we have displacement, delta x. So every kinematics problem only uses five variables, these five right here. I'm going to highlight them in yellow. V initial, V final, acceleration, time, and displacement. Every single constant acceleration problem is made from these five variables. So once again, look for constant acceleration problems. So this trick only works for these types of problems. So here's the trick. Every equation out of these five leaves one variable out. So let's build a flowchart to know which equation to use when. So for our flowchart, we're going to start up top with what is missing. What's missing, right? And then I'm going to draw five different nodes, one for each variable. So I'm going to say delta x here, v final, v initial, acceleration, and time. So again, we are not looking at what we have in the question. We are looking for what we don't have, what is missing. So if delta x is missing, if displacement is missing, we're going to use this equation. We're going to use v final is equal to v initial plus a t. Okay? Now, if we have v final missing, we're going to use the equation delta x is equal to vi times time plus 1/2 at squared. If initial velocity is missing, we're going to use delta x is equal to vf t minus 1/2 a t squared. This one is less common, but it still works. It's still similar off of the v final equation, but that is one I would write down as well. Now, if we have acceleration missing, we're going to use delta x is equal to v initial plus v final over 2 times time. And if time is missing, we're going to use v final squared is equal to v initial squared, this is an arrow, plus 2a delta x. So again, use these proper equations if the variable is missing. Oops. So start off with what's missing, write out your 5 variables, and then write the appropriate equation for when each variable is missing. And when I mean missing, I probably should have clarified this sooner, means that it is not mentioned in the problem as a given or as something you are looking for. All right? So that being said, let's go ahead and jump into an example. We have a car starts from rest and then has an acceleration of 2 meters per second squared for 6 seconds. Find the final velocity. So first things first is let's write all the variables we have. So we have initial velocity is 0 because it starts from rest. We have acceleration is 2 meters per second squared. We have time is 6 seconds. And then we have unknown. What we're trying to find is final velocity. Now, even though it is unknown, it is still mentioned in the equation. So what is missing? We are missing delta x, right? There's no displacement in mentioned or in this problem. So let's go back to our flowchart. So what's missing? We see delta x is missing. So we're going to use v final is equal to v initial plus a t. So we have v final is equal to v initial plus a t. Let's go ahead and plug that in. So v final is what we're trying to find. We know v initial is 0, acceleration is 2, and time is 6. V final is 12 meters per second. And that is our answer. So see how even when you're pressed for time, you don't actually have to memorize how to do everything. If you just use this flowchart, you can solve any problem. Let's do a few more examples. So we're going to go on to example 2. We have a ball is thrown upwards at 20 meters per second. How high does it go? So again, let's start with the variables we have. So we have v initial is 20. We know v final as well. It's not explicitly mentioned, but we know how high does it go is another way of saying what is the peak, how, right? What is the max height? So h max is what we're trying to find. So at h max, we know velocity has to be 0 because the ball goes up, it stops for a second, and then it comes back down. So at this point, velocity final is 0. So again, we have v final equals 0. We have acceleration, again, not explicitly said, but we can say that it is 9.8 meters per second squared, gravity. And then our unknown is delta x, right? How high, what is the displacement that it goes? So again, we have 4 out of 5 variables here. Which variable is missing? Time. So if we go back to our flowchart, we see if time is missing, we use this equation right here, which is v final squared is equal to v initial squared plus 2a delta, 2a delta x. All right, so let's plug this in. So we know v final is 0, v initial is 20 squared plus 2 times negative 9.8 meters per second times delta x. The reason I'm using negative is because the ball is moving upwards, so velocity is pointing this way, but acceleration is pointing in the opposite direction. So that is why the negative 9.8. So once we solve this and rearrange, we get delta x is equal to 20.4 meters. There we go. Let's do one final example. I'm going to have you guys try it on your own. So go ahead, pause the video, try this one on your own, and then once you do, we'll get back and work it through. All right, welcome back. Hopefully you had a chance to try it out. If not, again, pause. But here we go. So a runner begins moving at 4 meters per second and accelerates at 3 meters per second squared for 5 seconds. How far did he go? So again, start with what variables we have. We know v initial is 4, begins moving at 4 meters per second. We know acceleration is 3, and we know time is 5. Now the question is also asking how far did he go, which is another way of saying displacement. So there we go. Now with that, what variable is missing? V final, and we know V final. We go up here. So if V final is missing, we use delta x is equal to VIT plus 1/2 AT squared. So we're going to use that right here. So delta x is equal to V initial times time plus 1/2 AT squared. Let's plug everything in. So we have delta x is equal to 4 times 5 plus 1/2 3 times 5 squared. And once you plug all of this in, we get delta x is equal to 57.5 meters. And there you go. So that is how to use the flowchart to solve any constant acceleration kinematics problems. So again, here is the flowchart. You don't have to memorize 5 equations and memorize when to use which one. You just need to memorize this right here. You need to memorize what is missing and how to solve that way. Hopefully that helps, and I'll see you next time.